Here, let's say we've got a 40% chance of drawing. There's a 40% chance of drawing a green marble from a jar. Okay? If three are drawn without independently, if three are drawn independently, answer the following. Number one, what's the probability all are green? What is probability all are green? Well, again, this is not stated out as an and probability, but if I write it out, wouldn't it be the probability that it's green first and green second and green third? Wouldn't it be an and probability? I want all three green. So it's and green and green and green. Okay? So what does this mean? Well, this means multiply. Now, what does the independent mean? Well, remember, when events are independent, all you have to do is, you don't have to worry about conditional probabilities. If it's independent, you don't have to worry about conditional probabilities. Since they're independent, we don't have to worry about conditional. So, what I'm going to do here is, I'm just going to take the probability that it's green on the first, which is 40% chance, 0.40. Multiply it by green on the second, that's just going to be 0.40. And then the third one's green, 0.40. Yeah, these two are not going to change because they're independent. I just do 0.40, 0.40, 0.40, which is 0.064. And multiply those together to get 0.064. Yeah, just multiply because what's the word? The word is and. All right. Now, let's change it up and do the other side here. What is the probability none are green? All right, so we draw these marbles, three marbles. What's the probability that none of them, with this 40% chance of drawing a green, what's the probability none of them are green? Well, first one's not green, and the second one's not green, and the third one's not green. This is an and probability. I'm just doing the probability that it's not green. What is the probability that it's not green? 0.6? How do you get that? Well, if there's a 40% chance it's green, then 60% chance that it's not green, which is, move the decimal point 2 places back, 0.60 or 0.6. Yeah. Yeah, so the probability that it's not green, note, is 0.60 or 0.6. So what does this work out to be? Well, I do the probability that the first one's not green. What is it? 0.60 times the probability the second one's not green, 0.60, and the third one's not green, 0.60. Follow me on that? See where I get this? Because I'm doing not green. It's 40% green, 60% not green. So the probability here is 0.6. All of them are 0.6, which gives you 0.216. 21.6%. Is this okay?
Because it starts out in a percentage, do we need to finish in a percentage?
Yeah, that might be a good idea. Yes, since it started percentage, put this as a percentage. Yeah, I don't know that that's necessarily the case, but that is a good thought there. Okay. All right, let's do another one. Okay. In a certain city, the probability of catching a burglar is 30%. If a detective is assigned 3 independent cases, number 1, what's the probability all 3 are caught in that case? What is the probability all 3 are caught there? Well, this one's a lot like previous one, isn't it? Here I want, again, it's and is not stated there, but I want the probability that we catch the first one and second one and the third one. Catch all 3. So what do I do here? I'm going to take the probability the first one's caught, which is 0.30, right? Since it's 30%, move 2 places back. What about the second one? Is it 0.30, or do I know? Well, it's independent of the other one, so yeah, the second one being caught, doesn't it all depend on the first one being caught, so it's still 0.30, isn't it?
Why wouldn't that reduce down to 1?
It's independent. And independence, since they're independent, this one being caught doesn't affect at all the probability of this one being caught. If it's independent, it's not going to change. Nothing's going to change from one side to the other. What about the third one caught? What's the probability of it? Still 30%. 0.30. And means multiply, so I'm going to multiply those 3 together. 0.3, 0.3, 0.3 is 0.027 or 2.7%. Right? 2 places back. Okay. Now, let me do this one because you can mix and match. All right, what is the probability that the first one's caught but the second 2 are not? So the first case, he catches that burglar, but he strikes out on the second 2. What is the probability the first is caught and the second 2 are not caught. What are we going to do there? Well, if we write that one out, it would be what? Probability that it's first is caught, and what happens second? Not going to catch the second one, ands are not going to catch the third one. That's what I want. So what would I multiply there? Caught is 30%, 0.30. Not caught, what is it going to be? 70? If the probability of catching one is 30%, then the probability of not catching the burglar, Ray burglar, is 70, right? There's a 70% chance. Subtracted from 100. So, for the second one, what do I want in here? Well, it's going to be 70%, which is 0.70. And then the third one's not caught, so it's going to stay also 0.70 again. Those, like I said, they're not going to change across the board because it's independent. But now multiply those together, 0.30 times 0.70 times 0.70, 0.147, or 14.7%. Okay? So far, so good. All right, well, let me change up one other thing here. Get you to think about this. Number 3. What is the probability that exactly 2 are caught? What is the probability that exactly 2 are caught? Now, do you know anything about this one that's different than any probability problem I've come up with yet? It says exactly 2, and it doesn't say the order, right? You see that? What is the probability that exactly 2 are caught? This doesn't specify the order. So we have to think about that. Because there's a number of ways that I could do this. I could catch exactly 2 a number of ways. So if it doesn't specify the order, we got to think about, what does that mean I could do? Well, here's what it means. I could catch exactly 2. So I could catch number 1 and number 2, catch the first and catch the second, but not catch the third. See that? But I could do it a different way, right? How else could I do it? I could catch the first one, not the second one, but catch the third one. That would change it up, wouldn't it? Or how else? Not catch the first one, but catch the last 2. Whoop. See what I'm saying? The order that I catch them, change it up. Now, if I could do it this way, or this way, or this way. Okay, I'll say more about that in just a second. Now, when I go to the probabilities, what happens? Well, the probability that I catch the first one is 0.30. Probability I catch the second one is 0.30. And it's and, so I multiply. And the third one, I don't catch it on this first one, so that would be 0.70. 0.30, 0.70, I mean 0.30, 0.30, 0.70, which is 0.063. If you multiply those together, and means multiply. It is and, so I multiply those. Okay, what about the second one? 0.30, 0.70, 0.30. It's a little different order, but it's the same 3 numbers, isn't it? So I still get 0.063. Right? And then the third one is different order but the same numbers, 0.70, 0.30, 0.30. That's still multiplied together, 0.063. But that is three numbers. I've got to do something to get them into one number, okay? What do I do? What word is this? Or. What does or typically mean? And means multiply, or means add. Yep. So I'm going to add these because I've got this way, or this way, or this way. So you add them. 0.18. No. Yeah, 0.189. Or 18.9%. Right? Okay.